Next week we'll hear a computer graphics researcher who works for Pixar talk about something called nonlinearity, how much nonlinearity there should be in computer graphics. That's next week. Today I have the pleasure of introducing you to Dr. Wang from the University of California, Santa Barbara. He's going to tell us about natural language processing in the text. Great news. So let's welcome our speaker.
All right, thanks, George, for a very kind introduction. So it's my pleasure to be here. It was kind of fortunate to hear that, there's this big TOPS fire in here. In the past week, in Santa Barbara, we had similar situation this summer, right? So, when I was at my house, I can see clearly, the fire just wiped out the whole area, and then it actually blows over the mountain. It's just, part of the Goleta where I live also got evacuated, right? So I live in, Central Coast, right? So it's like 6-hour drive from here, but you can see that that's definitely a common issue. But hopefully, we are recovering and everything, will get better, right? So I learned that this is the second day, for the reopening of the campus. And today, let's talk about something interesting, right? So particularly, I'm going to talk about natural language processing, right? So this is my area. I got my PhD from Colloquium last year, and then took the faculty position in the computer science department at UCSB. So my areas are in natural language processing, machine learning, and AI. Okay, so let me give you first a gentle introduction to natural language processing, right? So what is natural language processing? That is the first agenda that we're going to look at today. And then I'll dig deeper into the problem of detecting fake news. So what is the motivation, and what are some related work in this area, and what is our approach? I'll talk about some experiments that we did, and also talk about some other research activities that we're doing at UCSB. Okay, so natural language understanding, right? So natural language, honestly, very easy for human, right? So when you talk to your friends, you don't think about it, right? So you just know how to, say that word, understand what other people want to say. So the difficulty here is that machines are not designed to understand human language, right? So if you want to talk to machine, it's incredibly difficult because, it's basically logic, 0 and 1s in a machine, right? So how do you actually teach machines to understand human language? That is something very challenging, okay? So can you imagine that right now life's already getting better, but what about, scheduling an appointment with a professor, scheduling, some activities with your friends? Still, we spend a lot of time, on emails, waste a lot of time. But imagine in the future, what if we have an assistant, personal assistant that can help us to deal with this, right? So also, right now, let's say if you want to book your next vacation, it just takes you huge amount of time, right, to find out what is the cheapest, rental cars, hotel, should I do Airbnb or not, right? So this takes you a really long time to make that decision. But in the future, if someone can do that for you, understand natural language, understand your meaning, can have a dialogue with you, I think that would be something really fun. Okay, so in general, what natural language understanding means is that text is just, huge amount of text documents, text data out there. But the thing is, how do you actually distill the knowledge out of the text documents, right? So that is a key of natural language processing and natural language understanding, okay? So NLP, you already see a lot of applications, right? So human language text is NLP, speech is also natural language processing. Sometimes NLP also deal with web pages, social network data, and also genomic sequences, right? And there are a lot of applications you're already seeing, right? So question answering, for example, personal assistants. Everybody at some point may have tried Siri or Cortana or Google, Google Home or Alexa. There are a lot of assistants these days, and also chatbots, right? So chatbots also very popular these days. So you can see that in the commercial world, right? So NLP already has a lot of applications. not just this chat box that I talk about, but there's also implicitly there are things you're not aware of that people are using NLP. For example, Amazon reviews, right? So how do you know whether this is a fake review, right, or this is an authentic review? So honestly, there are a lot of sellers, they hire people to write fake reviews, right? So this is very common. But can you design algorithms to tell which one is fake review, which one is actually authentic review by the actual buyers? So this is very important to Amazon. And for Facebook, Twitter, there are also a lot of tasks they have to deal with, right? So for example, will you be able to build an algorithm that can, for example, detect if someone has a suicidal tendencies, right? So this is very critical, and actually, I think Facebook had some success stories in that area. And for Twitter sentiment analysis, you can see that there are also a lot of commercial applications as well. So this is kind of an example, right? So I gave to my student in the information extraction example. When I was talking to my students about scheduling TA meetings, right? Sometimes you have to get to the TAs back and forth because there's their schedule, there's your schedule. You send a couple of emails, but would it be possible to use information extraction and automatically trying to create this calendar, right? So this one should be here. So to create this kind of calendars, right? So you can see that if you have used Gmail before, Gmail already started trying to do this kind of things. It's still not perfect, but information extraction will be really useful, right? So you don't have to, actually put the things on a calendar, but actually, with information extraction, we can know what is the event, what is the date, right? So what is start and end time, and then what is the location. So you can use information extraction techniques to fill in the slots and just put that automatically on your calendar, okay? Sentiment analysis is also another very interesting area in natural language processing. So let me show you an example of how this might be useful. So this is a New York Times example of emotional spell check. Yeah, so in this example, you can see that sentiment analysis definitely very useful, right? So this particular example, but for Yelp and for many of the businesses, they want to understand the emotions in text, right? So this is a specific area in natural language processing called sentiment analysis and opinion mining, right? So the goal is to actually trying to understand, can we understand the sentiments in any piece of text data, right? So it could be from a product, marketing point of view. It can also be from political opinion tracking point of view, or from a social network analysis point of view, right? So there are a lot of things you can do. So also want to show you one example about blog analytics, right? So really nobody writes blogs these days, but at some point these are actually really popular. I mean, there are still people writing technical blogs, but can you imagine you can use the similar techniques to run it on Twitter data and trying to understand, the posts and also this kind of short text, right? So this is one example that linguistics and linguistic people and also computer scientists have been looking at. So this is essentially, on trying to understand the usage of the words I, me, and my on or after September 11, right? So 2001. So in this case, you can see that this is exactly September 11, right? So and then there's significant drop on the usage of I, me, and my on these pronouns, right? And then linguists also track the usage of pronouns like we, us, and our, right, in this context. And then realize that after September 11, there is a surge, right, as you can see from here, September 12th, that people started to use more of, we, us, and our to show, this kind of specific events that you can see from this linguistic data. So if you actually trying to understand the twist for the recent Sonoma County fire, and you may be able to see similar things, right? So you can basically analyze the usage of language and trying to understand how that correlates with the actual events, okay? Before we started, I was talking to George, and then we discussed, not just text, right? So natural language processing also deal with speech as well. So in my own research, we've been looking at, understanding deception, intoxication, and also emotions from speech data as well, right? So as you can see, let me see if I can play these examples.
Yes.
So this is trying to understand whether a person is annoyed or not, right?
No, I am departing from Jacksonville.
There is no Manila in Montana. Anytime.
Yeah, so it is interesting that you see that people have very different, prosodic cues, right? Depending on gender, depending on the language usage, depending on the pragmatics. So there are a lot of work that we've been looking at is looking at these paralinguistic cues. For example, you can imagine that you can deploy that in the call centers, right? So to track, the performance of the salesperson and also the agents, and then can understand, what exactly, do the customers need and trying to improve the customer experience, right? So there's huge market there. There's $1 billion market there on call centers. How do you design dialogue systems that is capable to answer these basic things for you and be able to, really help the customers lower down the cost from the company's perspective, and also trying to make the conversation flowing more naturally. Okay, so another example about sentiment analysis that people have been looking at is basically the review data, right? So talk about a Yelp review, but how does the language actually related to, the dollar signs, right? So how does the language of sex, drugs, and, this kind of language is related to the restaurant review. So we also found some interesting things. For example, we see that people say this, kind of use the language about sex to actually indicate that in some of the reviews saying things like seductively seared foie gras. And then the interesting thing we found is that there's a strong correlation with the restaurant price and also the how people are likely to use the language about sex to describe this food, right? So you can see that this is $1 sign is very less likely, but then when you go to really fine dining restaurants, very high-end restaurants, people are more likely to use the language, about sex to describe the food, right? So another interesting thing is that we also study drugs, right? So we found that people also use this kind of like language about drugs for the food reviews. For example, the fries are like crack, and then they're so addicted to pepper shooters, and then garlic noodles, my drug of choice. So you can see that there's also this kind of drug language in food reviews. But there's another thing we found is that there's very interesting correlation between the price as well. So you see that people go to fast food, very cheap restaurants and use a lot of language about the drug language, but you won't expect people saying, well, my foie gras is like crack, right? So nobody really says that. So there's very interesting things you can understand about language and how that correlates, with some of the specific language that we use. Okay. So this is sentiment analysis, right? So it's all basic areas within natural language processing, and people have also used natural language processing to solve some real world biology issues. For example, finding the genome sequences that is related to, for example, specific disease, right? So you can imagine it's very difficult for human to do that because the genome sequence is just impossible for human to read it, right? So for any biologist, there's no way you can read that by your eyes, okay? So the way to do that in NLP is that you can build one thing called language model, right? And understand the transition between the, these letters, right? So TAG, TGA, TAA, how do they go from one to another? So essentially you can build language models and find the sequences, right, that really matters and what are the special ones. And you can actually align the genomic sequences and find the genes that, specifically related to one particular function. And this will actually help, biologists to study evolution and also help, scientists to understand disease and relationship between, genes and disease, okay? All right, So yeah, so that's ConvNet application of NLP. Also want to talk about IBM's Watson, which is very classic example in question answering, right? So this was back into 2011, just in case you haven't seen this video.
Good morning, everybody. Thank you for being here. What do you say we play Jeopardy? Let's get right into the Jeopardy round. These categories: a man, a plane, a canal, Erie, Chicks Dig Me, children's book titles, My Michelle, MC5, and finally, vocabulary. Ken, you're in the first position. Please make a selection.
I've never said this on TV. Chicks Dig Me for 200, please, sir.
Kathleen Kenyon's excavation of this city, mentioned in Joshua, showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her archaeologist hubby dug in hopes of finding the lost Syrian city of Urkesh. Watson.
Who is Agatha Christie?
Correct.
Same category, 600.
At the Olduvai Gorge in 1959, she and hubby Lewis found a 1.75 million year old Australopithecus horsey-eyed skull. Watson.
Who is Mary Leakey?
You're right.
800, same category.
Harriet Boyd Hawes was the first woman to discover.
Yeah, so I think you got an idea right now, right? So definitely Watson was a very successful story of question answering, right? So IBM spent millions of dollars and actually hired a really large team working on Watson. For a period of 2 or 3 years, and then they were actually very successfully to actually build this question answering agents just based on very simple machine learning techniques, right? So they collect a lot of questions and answers for these Jeopardy games, and then they train a very simple classifier that actually maps the questions to answers, right? So a sequence of classification actions, and then they can decide from all these candidate answers, right? So which one is more likely? So this was very successful story because Ken Jennings is really good. So he's won Jeopardy so many times, and before that, nobody actually know that actually machines can actually beat human on these very difficult trivial games. Okay, so. All right, and then there's definitely personal assistants, right? So already you know personal assistant. Just want to ask, how many of you actually are using Siri or Cortana, whatever assistant, every day? Raise your hand if you use it every day. Okay, I only see one person, right? So, two. Okay, so this is not surprising, right? So even I work in this area, I don't use it every day. Okay, the reason is because still there are a lot of things that can be improved, right? So there are simple things. If you want to set up an alarm, definitely you can do that right now. Very easy. You don't have to, go and type other stuff. But definitely there are things that needs to be improved, right? For example, co-reference, and also understanding long-term interactions, and for this kind of personal assistant to help you with more challenging tasks. Right, so I don't know whether you've noticed or not, right? So last year, actually, Mark Zuckerberg had this personal assistant challenge, right? So, he was saying, my personal challenge for 2016 was actually to build a simple AI to run my home. Okay, and then at the end of that year, he actually had some success. So you can look at, in the future, what this personal assistant might look like.
Good morning, Jarvis.
Good morning, Mark. It's Saturday, so you only have 5 meetings. Room temperature is set to a cool 68 degrees.
Earlier this year, I started building a simple AI to help run our home. I talked to Jarvis using this app I built. It uses artificial intelligence to understand me and figure out what to do.
Max woke up a few minutes ago. I'm entertaining her.
All right, let's go check on her.
Let's practice our Mandarin.
Jarvis, your Mandarin is so soothing.
Shish.
Jarvis also helps me get ready in the morning. Fresh shirt.
Fire in the hole.
Hell yeah. Jarvis knows when to make me breakfast.
Your toast is ready.
All right. It's time for my call with Shrek. Can you get him on the video conference line?
Setting up the VC room now. Remember to check on the AI guidance system for Aquila.
One of the best things about Jarvis is it can recognize people at the gate, let them in automatically, and then just tell me about it.
Mark, your parents are coming in.
Frank? Jeffrey?
It's Jarvis.
And Jarvis can play all of our favorite music. Hey, play us some good Nickelback songs.
I'm sorry, Mark. I'm afraid I can't do that. There are no good Nickelback songs.
Good. That was actually a test. Okay, how about just play some songs that our whole family likes? What? I'm a dad now. This is what I listen to. Jarvis also likes to join our family for playtime. Who should we tickle next?
I think we should tickle Max.
I'm also experimenting with other voices.
Stop her! She's getting away! Do it now!
And if I don't want to talk, I can just text Jarvis through a messenger bot that I built.
Mark, I'm trying to read in here.
Yeah, my bad. So this has been pretty fun, but I need some more ideas for Jarvis, so leave them in the comments and I'll try to build some of them. Alright, movie time, Jarvis.
You got it, Mark.
First, I need to teach you to make me some more popcorn.
All right, so as you can see this example, right? So I think I'm fine with most of the part of the video. It's just probably I don't want to have Morgan Freeman wake me up every morning. That sounds a little bit too much. All right, so but I think, I just want to, give you some motivation about, some things that you actually use every day. Actually, these are all powered by natural language processing techniques. Right, so today, so that's just a background, but today I'm going to talk about fake news detection, right? So this is my own research, and I think it's a very interesting area to look at, okay? So definitely, I think important lessons now is that fake news is destroying the journalism, right? So if you look at the New York Times standards and access, right? So I think it's important for news to be fair, right? Everybody has their own standard, but at least understand fairness is important, and also integrity, right? So it should be accurate, right? So the reporters should try their best to report things that are accurate and things that are correct, right? And then whether large or small, right? And also truth, I think, is really important. So I didn't go to journalism school, but I think these are some basic concepts that actually people also teach in journalism schools, is that also news has to be truthful, right? So it must, we cannot tolerate any plagiarism, and we cannot, tolerate any kind of like fake news that people specifically know that is fake news, but they just want to, have this kind of viral, things that going on in the social network, but just to spread the fake news. Of course, it's creating a political turmoil, right? So as you can see from this picture, right? So it says, don't believe everything you read on the internet just because there's a picture with a quote next to it, right? And then Abraham Lincoln said that. Okay, so you can see that definitely, there are a lot of things like this, right? So they pretend that, this is some quote like from some famous people, but it is not, right? So people just use Photoshop and make these things up. Okay, so I think these things are still okay if you don't care about politics, right? But then I think fake news has started to actually create, some real life fears these days. Okay, if you still remember the Pizzagate thing from last year, this is definitely something very serious, right? So this guy actually read a piece of fake news on the internet, and actually this person brought an AK-47 to a pizza shop and started shooting. Okay, so this is really bad because you want to go to lunch, but then you don't want this kind of things to happen on campus, right, or anything like this to happen. So there are definitely things that we should be really cautious about fake news. And is there anything we can learn about fake news? How people use the language to actually write fake news? I think these are actually really important questions. Computer scientists can look at, right? Because in old days, computer science is more about classic, things, for example, algorithm theory, operating systems. These things are still really important, but I think going to the future, we also want to understand how computer science can actually help other areas, right? How do you actually use computer science to solve some societal issues? Okay, so I just want to give you a quick pop quiz and see if you're good at doing this, right? So there's one particular quote from Rick Perry that says, America produces more oil and gas than any other nations in the world, right? So it's a pop quiz. How many of you think this is true? One, okay. How many of you, two, think it's true? How many of you think this is false? Okay, a lot of people think this is false, right? So the answer is this is true. So the reason is that if you look at U.S. Energy Information Administration document, right? So it was showing that under a comprehensive measure, the U.S. produced 14 million barrels of oil a day in the third quarter of last year, right? So this was tops in the world, ahead of number 2, Saudi Arabia. Okay, so U.S. is actually number 1, and then Russia was number 3, and U.S. had lead Saudi Arabia since the last 3 months of 2012, right? So it's already, have that ranking, many years ago. So similar ranking also holds for gas. So what I'm trying to tell you from this very quick example is that human may also be very bad, actually, trying to tell whether that particular code is true or false, right? So language definitely, is one thing, but there may be more things you need to look at to help identify whether that statement is true or false. Okay, so but before we go into the detailed approach, I just want to tell you more background about deception detection in natural language processing, right? So this is not the first problem of deception detection in NLP. So if you remember earlier in the talk, I mentioned there's fake reviews, right? The fake reviews is also very serious. So people actually been working on detecting deceptive reviews for the past 5 or 6 years. So there are people looking at linguistic patterns, right? So within that sentence, are there any specific linguistic patterns, for example, syntax or semantics that people use to actually express, fake reviews, right? And then there's also people look at, how do you create the positive cases, right? Because you can imagine now, if we're going to use machine learning to solve this problem, we need some examples to teach machines to understand what is fake review, right? What is, the authentic review. This is incredibly difficult, right? So the reason is because when you just look at one particular review, just like, for example, that example we went through, very difficult to tell for human annotators to tell whether this is true or false. Okay, so one thing that people look at is the idea of using crowdsourcing, right? So essentially, they go to Amazon Mechanical Turk and ask people to write fake reviews, right? Specifically, tell you that you should write fake review. So then we can collect those examples as training data. So we know for sure those are fake reviews, right? So that's an alternative approach, to having people to do the annotation. Okay, and there are also people look at stylometric approaches. For example, trying to see how the the genre of fake review is different from, let's say, the news articles, right? How is that different from the normal text data? So you can also do this kind of comparative studies. There's also people recently looking at the semi-supervised learning. So the challenge, so I don't know how many of you know machine learning, but roughly there are 3 kinds of machine learning approaches. One is supervised learning, right? So you feed machines these examples, true examples, false examples, right? And there's also, semi-supervised learning where you have some unlabeled data. You don't know whether it's positive or negative example, but then you can use some seed data and label this unlabeled example and use everything to build your classifier. Okay, so but then still there are challenges, right? So this is basically deceptive reviews, but the challenging thing in general you can see is very difficult to get data, right? So if you don't have any data, it's very difficult to build statistical models and trying to understand this kind of patterns. Okay, and also another challenge is that if you train on the crowdsourcing data and then test on Yelp, right? You can see that there's a mismatch between the domain, right? So you get the data from Amazon, but you test it, let's say on Yelp reviews, and then there's definitely a mismatch between the domains, and then the results sometimes are really bad because either the examples you feed it to the machine are too fake in the training time, or it does not match with the real-world distribution in the testing time. Okay, so the other thing I want to mention is that fake news detection is actually more challenging than detecting deceptive reviews. Reason is because, for example, you can see that the reviews are much longer, right? But then for that particular quote, it's just very short, right? For review, Yelp review, at least you have a paragraph to deal with. But for fake news, you only have one quote, right? So it can be from a campaign, can be from an interview, can be from newspaper ad. So those are actually very difficult to deal with because those quotes are very short. Right, so definitely much more challenging. And the domain, as you can see in the review case, is usually very focused in a particular domain. For example, restaurant review, right? So product review. But for fake news, anything can be taken from any particular venues. Like I said, there's ad, right? So there's a debate, right? There's a TV interview, right? And then there's something showing on Facebook, something showing up on Twitter. So all these different sources, how do you deal with very complex domain and build machine learning algorithm to deal with that? Definitely you can see another thing is that the subjects, right? So in this case, the restaurant domain are relatively limited, right? So, but then in reality, when you deal with fake news, any politicians, any people can be the subjects, right? So detecting fake review, like I said, usually very short statements, very diverse domains, Twitter, Facebook, debate, interviews, TV ads, and the subjects can be literally anything, right? So the most challenging thing is that for fake news, there are no data sets, right? So, you want to do fake news detection, but without having the initial collection of data set, it's very difficult to deal with that. So for my team in the past year, we've been looking at a way to collect a new data set to do fake news detection, right? So one particular source that we've been looking at is this website called politicfact.com. So this is a Pulitzer Award prize-winning website that spent more than 10 years having all these editors go through the fake news and having these editors actually go through the supporting documents and verify whether this is true or false, right? So this is one of the better things we can find. Not saying this is 100% perfect source, but then definitely this is something I think very useful to our study. So I basically went ahead and collected about 12.8K statements from this, and also the deep data analysis and supporting evidence for all these quotes, right? All these short quotes. And then we obtained some very fine-grained labels for every single quote, right? So we know whether it's really false, right? Pants on fire, or false, or barely true, or half true, or mostly true, or true, right? So we have very fine-grained labels with every single statement. The venues are actually quite diverse. So there are tweets, debates, and posts, and speech, and interviews, news release. We collected data from all these different domains. And then there are a lot of subjects that people discuss, right? So for example, economy, healthcare, tax, budget, these are the standard things that politicians, they discuss all the time, okay? So here's a random snippet from Liar, right? So for example, the statement, the newly elected Republican senators signed pledge to eliminate food stamp programs in 2015, right? So for this one, we know that the speaker is someone from Facebook, right? So it's social media posting. And then label is pants on fire by the editors. The judgment is that basically the editor went through the website, right? They actually originally have this statement. And then they actually talked to the website owners and realized that's actually parody website, right? So they don't say this is they are a parody website, but then turned out this is actually from the parody websites, kind of like the audience, right? And then they rated this pants on fire. Okay, so so this is just one example. We have about 12K of these examples labeled by the senior editors from Political Fact. And then for this data set, we basically want to divide them into different subsets, right? So we can train our machine learning models on some training set and test on some testing set, right? So we basically put about 80% in the training, some of them 10% in validation, about another 10% in testing set, right? So the average length is about 17 words for the statements. And then there are roughly hard to get a balance, but roughly relatively balanced distribution of speaker affiliations, and then there are also things just come from internet. So this is much larger than the previous resources that we can build on for these classifiers. Okay, and we also have the credit history that for each speaker we know distribution of labels in the past. For example, how likely is this person to make false statements in the past? Okay, and then we went ahead and designed a deep neural network for this task, right? So, so definitely there are a lot of things you can learn about neural networks. So I actually spent a quarter teaching neural network. But then this is just a rough story, right? So in the beginning you have some input, right? So this is essentially your statement. Okay. okay? And then you also have some metadata. So the idea is that you want to build a convolutional neural network to look at the dependencies between the bigrams, unigram, and trigrams, right? So if there are 2 words, it's a bigram. 3 words is a trigram, right? So you want to look at the interaction between single word, bigram, and 3 words, right? And then you can basically do some nonlinear processing, right? And these are basically called feature maps. So you basically create a window, you slide down this bigram window, and you create this feature map for the bigram representation of your input statement, right? You do that for trigram and also other features you can come up with. At the end, you do max pooling. Basically, these are all these different numbers. You just take the max, and then that is basically your sentence representation. Okay, and then you can also do similar things with the metadata to build a convolutional neural network and a sequential neural network on top of that, and get you the sentence representation. Finally, when you're trying to make a prediction whether this is true or false, right? You can use a softmax function that is basically a distribution on multinomial candidates. Okay, and then at the end, you know how likely this is going to be true or false or somewhere in the middle. Okay, and then we had some preliminary results from this model. So essentially, we tried a whole bunch of different machine learning tools. For example, SVM, logistic regression, this kind of sequential deep learning models, and also this convolutional deep deep models, and actually found that a convolutional model gives the best performance. And then when you combine the model with this kind of metadata, for example, speaker information, there's some small improvement on top of that. Okay, so essentially what this is suggesting is that it is promising in the sense that it's much better than about 30% better than a random prediction, right? It's already 30% better, but then still it is very challenging issue, right? So what the results are suggesting is that really based on previous study, right? So based on manual detection of fake news, we can say that it's very consistent with the human result, right? So for both human and machine, if you only look at that particular short statement, it is very difficult, right, to tell whether this is fake or true, right? So, and also if you have a fine-grained label like what I did in the experiment, it's even harder. But I think another thing is that adding the metadata really help, right? But I think, I also want to give you a bright future for this line of research is that you can imagine that the reason why the result was not like the, 80 or 90% accurate is that there's no source that we use to actually do fact checking, right? So fact checking is really important. So in addition to look at a sentence, you want to have some supporting document, right? Such that you can teach a machine to look at these supporting documents and be able to figure out whether this is true or false, right? So one thing that we've been looking at is automated fact checking. So for example, you have some source document that you found from somewhere. Essentially, you can look at their linguistic structure, right? So you can look at what is the head word, right? So what is the verb for this particular sentence, right? And then that is the root of this dependency parse tree. And then you have the subject, right? So she is the subject. And then you have some objects, right? For example, midnight train, that is the object. Then you can comprise this triple representation that has the subject, verb, and object, right? So you can look at these triples from the text documents and also look at your source statement and compare them and see whether they are the same or not, right? So this is one thing that I've been looking at. So hopefully with some coreference anti-detecting, we'll have better solutions in these areas, okay? Another idea is that, so that's OpenIE, so we don't define what kind of relation we're looking at. Another idea is to look at, this kind of Wikipedia free-base style detection where we actually use predefined relations, predefined schemas, like the ones you've seen in boldface. We can use those kind of things actually as relations and to extract, facts from text data rather than using open relations, okay? So in this case, we can know for sure what different relations are and how they are related to each other, right? So we can deal with much more complicated cases, but then still there are challenges, right? So as you can see, dealing with numbers and temporal expressions in this neural network is still very difficult. So if someone made a statement and then they just flip a number, okay, you have to really teach machines to go look at the supporting documents and be able to understand that there's a discrepancy, that they just changed the number, right? But then these documents, there are no format, right? So everything is just really unstructured. So still, this is one of the major challenges in this area. Okay, so I think I still have 5 minutes. I want to briefly tell you what about some other works that we're working in the Natural Language Processing Lab at UCSB. Okay, so we have about 10 PhD students and about 20 people in general, combining undergrad, masters, and everyone together. So we won't work on many different areas in NLP. For example, information extraction, relation extraction, fact checking. That's a very classic example of information extraction. So we also work on summarization. So given a long document, can you build machine learning algorithms that go from the source sequence, right? So the source documents to a single sentence summary. So that's the thing we've been looking at. So we also look at social media tags, for example, slants. How do you actually build models to understand slants and how slants are made of, right? So by looking at morphology, are there some specific rules that people make up these slants, and can you define, a machine learning model that actually can help you to explain the slant expressions that no one has seen it before? Okay, and then for language and vision, we've been looking at video captioning. So given a long video, let's say half an hour, can you use machine learning and be able to, for example, in this case, generate a summary and generate some captions for these videos? For speech, we've been looking at task-oriented neural dialogue systems, so basically combining specific tasks with neural networks and be able to see whether you can build a system that can, for example, solve more complex tasks, let's say book a ticket for your next trip. In the machine learning aspects, we've been looking at statistical relation learning, so this is a specific area in machine learning, and also been looking at deep learning. How do you build the sequence models, for example, to do summarization and this kind of related tasks. Structural learning is about learning the structure for neural networks, so this is another key things we've been looking at. And reinforcement learning, I haven't got much time to talk about it, but some of you may have heard of AlphaGo, right? So there are a lot of success in reinforcement learning for Atari games, Google's AlphaGo, but it's still very challenging for NLP problems because we don't know what is the ground truth and what is, for many problems we don't know what is the best objective functions to deal with. Okay, and then for AI in general, we've been looking at knowledge representation, reasoning, and knowledge graph, those kind of stuff. So there are some projects that I've been looking at. So I'll skip some one. So this is reasoning project that we're trying to basically learn in the knowledge graph and trying to give you better result. For example, right now, if you go to Google and ask, when did SSU establish, right? So it will tell you a specific answer that particular year. So this is supported by knowledge graph. Okay, so my work in knowledge graph domain is that given some background knowledge graph, can you actually infer some reasoning paths for you to fill out the missing information, right? So if you ask a more complicated thing, for example, when did Darwin Hall establish, right? So you can actually try to use the background information and try to infer the missing link. Okay, so this is one of our recent work. So we're also looking at something in the area of adversarial learning to do better sampling. So this is related to statistics. And briefly talk about summarization, which is given a very long document, can you create this kind of short summaries, right? So we've been designing this kind of sequence-to-sequence models and trying to understand whether we can build better sequence-to-sequence models to generate human-readable summaries. So this is another thing that is quite fun. So I don't have much time left, but you can imagine that one of the challenges for artificial intelligence is to teach machines to understand human language, right? And also generating, human emotions is incredibly difficult for machines as well. So one particular challenge is that you don't have training data for that again, right? So in this case, we actually went ahead to Twitter and crawled a few million tweets. Okay, so what we did is that we see if you're using this emoji, that we say this is probably the emotion label that you implicitly labeled for that sentence, right? And then we can build deep learning models and trying to see whether we can teach machines to generate emotional sentences, right? So turned out to be very successful. So given a particular context, right? So we can actually fit in emotion and manipulate the emotions in the response, right? For example, for the baseline model that we're looking at, it is very similar. It always says I'm sorry, but then for our model, you can see that if you actually say you want to use this kind of praying sign, and then you can see the text praying is actually generated, right? And then there's also other things you can see that is basically conditioned on the labels. Okay, so I think this is already 12:45, and I would like to just stop here. And again, thank you all for coming, and let me know if you have any questions.
I'm open for questions. I have a very quick question.
Mm-hmm.
How do you distinguish accidentally incorrect news from intentionally fake news?
You mean, what do you mean by accidental?
Somebody wanted to write correct news, but
Mhm.
couldn't, or relied on incorrect sources.
Right, yeah. So I think this is definitely a challenge, right? So the reason why we want to build this model is actually trying to help the journalists, right? So we want to help them to give them more choices, right? So when they are writing the news, right, they can send it to the detector. So the detector can make some suggestions, right? So what does the detector think about this particular piece of statement, right? So essentially what we're doing is to build a model that, for example, is trained on, 12,000 of this previous statements, previous news, right? And then essentially the machine learning model can give you a posterior distribution telling you how likely this is going to be fake or true. And then further on, if we have a model for fact checking, then we can also make some suggestions about whether there are some resources you can look at and what are some candidate answers you can have, right? So I think essentially, I think for machine learning, it is really a good tool for journalists, and then hopefully it can help journalists to write better news articles, and actually, for example, suggest you should probably write it this way to avoid making the confusions, right? So so that is something that is, I think,
Other
would be good.
questions?
Yeah, so when you have something that essentially detects and gives you a rating for, essentially how fake something looks, how do you avoid people using that to then craft the perfect fake item? It's just like, passing something through an SEO analysis tool. You keep working at it until you get it to it passes. I mean, you could do the same thing with something like this, couldn't you?
Yeah. I think that's a very good point. So I think in computer science and AI, researchers have, they are aware of these issues, right? So there are definitely, misuse of technology, right? And also there's, use for technology for good purposes, right? So this kind of things, I think right now there are researchers in the area who's actually working with, faculty in the law school and also faculty in other areas and see, whether we should be regularizing AI or, regularizing this kind of models, or what kind of constraints we should put. So this is definitely something computer scientists cannot solve by themselves, right? So this will have to be, collective, project that involves, let's say economists, lawmakers, policymakers, and also, computer scientists trying to figure out what would be the best solution here. You don't want to put too much restrictions on the development. On the other hand, you want to make sure that people don't misuse this kind of technologies. Okay.
Other questions?
In the Jeopardy question, I particularly noticed with the question about Susan Leak that there were keywords up front. And I wondered if you had experimented at all, or if anybody has, about are there ways that you can ask a question that benefit the computer and other ways that you can ask a question that benefit the human? Because if it seems to me that the more concrete keywords you put up front, the more time the computer has to search its database. Whereas if you flip it, it might benefit the human. Is there anything?
Yeah, I think that's an excellent question. So there are people actually studying paraphrases, right? So for example, exactly the same question, are there any different ways to ask the same question? So in NLP, there's a specific resource called PPDB, Parallel Discourse Tree Bank. So this kind of tree bank actually gives you a lot of, aligned data to tell you this, okay, so these pair are actually the paraphrases, right? So I haven't tested that, but I think that is a definitely excellent research question for maybe cognitive scientists and computer scientists as well to figure out, when you see the first few words, right? So what is that triggering word, right? Is there any keyword words that, really triggers machines to, for example, go through this route to search? I think that is definitely quite possible, right? Because I would imagine for Watson is using this kind of incremental decoding model rather than, seeing the whole thing and then decode. So the machine learning model, there are weights associated with every single word. So there gotta be some words with higher weights to actually trigger this kind of prediction. So I haven't looked at that, but I think that's something very interesting. To look for.
Other interesting questions? Any fake questions? Well, thank you.